Alright, for our two-way mixed ANOVAs in SPSS, I have provided you guys with an example research scenario. So we have a researcher was interested in discovering whether the intensity of an exercise training program had an effect on cholesterol concentration over a 6-month period. Similar to the previous examples that we've had in this class, I've highlighted our independent variables in yellow and the dependent variable in green. In our methods, we have 45 sedentary participants were randomly sampled and equally divided into 3 groups. So that equally divided into 3 groups component of our methods is going to hint that we have a between subject variable. Then we say in one group, participants did not change their current sedentary lifestyle. So I've identified the sedentary group as our control group, so 0 intensity. In another group, participants underwent a low intensity exercise training program that expended 1,000 kilocalories per week. And then the third group underwent a high intensity training program that also expended 1,000 kilocalories per week, but therefore exercised for a total lower time. All interventions lasted 6 months. Cholesterol concentration was measured prior to the intervention, midway, and at the end of the intervention. So these would be the time points that we are collecting each subject at, which means that we have a within subject variable of time. Our dependent variable is cholesterol concentration because that is what we are directly measuring. So if we pull all of this out into a nice little flowchart, our independent variable A we'll say is our exercise intensity. So we have our sedentary control group, which would be considered a 0 intensity. We have our low intensity group, which will be abbreviated in our outputs as INT1. And then we have our high intensity group, which will be abbreviated as INT2. So for exercise intensity, we have 3 levels of our independent variable A. For independent variable B, which is representing the different time points that we're collecting the cholesterol concentration, we have a baseline or a pre-measurement, a mid-measurement at the 3-month mark, and then our post-intervention measurement at the 6-month mark. So again, we have 3 levels of independent variable B for time. So when we are trying to think about what we would call this test, we still have the same components that are needed for naming a two-way ANOVA. So we have to indicate the number of independent variables that we have, so either calling it a two-way or a level-by-level description. So in this case, it would be a 3x3. And then the types of samples that we have, we know one of our variables is a between subject sample. So that would be our exercise intensity because we had said in the research scenario that we divided everybody into 3 equal groups. And then we know we also have a within subject factor, which is our time point because everybody is measured 3 times at different time points in the intervention. So we could use a naming convention between within to represent each of the types of independent variables we have, or we can just say it's a mixed ANOVA. It is important to note that the order of the levels should match the order of between within. So if you're using the level by level and the between within descriptors, the first level that you mention should match the between subject factor, and the second level you list should match the within subject factor. For this one, 3x3, it doesn't end up mattering because you have 3 levels of each. However, if, let's say, we had sedentary versus a low intensity exercise program only, that would be 2 levels of our exercise intensity, and we would say that we have a 2x3 between within ANOVA, right? Because 2 would be representing the between and 3 would be representing the within measure. So order does matter, just pay attention to if you're using a level by level naming convention. But with all of these different combinations, we end up with 4 different examples of how we could name this particular ANOVA for this research scenario. All right. When we put our data into SPSS, I'm going to highlight 2 different things in the variable view. The first one is for the between subject factor, which we should see in the first row of our variable view. So this group is indicating our exercise intensities, and it's a nominal variable. We kind of already know that, but we kind of we're going to be mixing how we organized our data for independent ANOVAs and repeated measures ANOVAs into one variable view. So we should have our between subject factor listed as nominal, and then we also need to identify the values that are going to be separating each of our exercise intensity groups. For repeated measures ANOVAs, or when we have a within subject factor, you'll recall that each variable, or when we're in our data view, each column, which represents our variables, should represent a level of our within subject factor. So because time has 3 levels, we therefore have 3 variables that are representing the levels of time. So our pre, our mid, and our post measurements for our cholesterol concentration. And because the numbers under each of these columns represent the measured cholesterol concentration, each of these measures should be listed as scale. Now, this is an example where we have 3 between subject levels and 3 within subject levels. Each variable number, so if we count down this way, right, represents a level of the within subject independent variable. So if we only had 2 levels, we would only have 2 rows in this variable view. If we had 5 levels, we would have 5 rows. Okay? So this number can possibly change based on the number of levels of the independent or the within subject independent variable that you're working with. Once we have this set up in our variable view, our data view should end up looking something like this, and we have 45 subjects, so this would extend all the way down to 45. But we have our between subject factor that's identifying our different groups, right? Control versus our low intensity, and then there would be labels of 2 for our high intensity exercise programs. And then for each subject within each group, we have 3 measurements for the pre, the mid, and the post cholesterol concentration. So these values actually represent the cholesterol concentration measured at each of those 3 time points. When we go into setting up our test, similar to our previous examples, we're going to assume that our dependent variables are normally distributed with no significant outliers. To set up the test, we're going to take a similar pathway that we did last week, where we go to Analyze, General Linear Model, and then Repeated Measures. When we have that taken care of, this Define Factors box should pop up, where you can identify your within subject variable. So in this case, it's time, which has 3 levels. Once you've identified the label and the number of levels, you can click Add. That will put it into this box here. And then we can insert our measure name, which is cholesterol. You click Add. That would put it into this box. And then once we have that set up, we can click Define. And that will end up defining our within subject factor, how many levels it has, and then it'll match it with the dependent variable measure of interest. So we would end up with something that looks like this, where in parentheses we see time. We have 3 levels of time with 3 different cholesterol measurements. So in our within subject variables section, that was our pre, mid, and post time points. Let's say that level 1 is pre, level 2 is mid, and level 3 is post. Okay, so 1, 2, 3. We could highlight all 3 of these and transfer them into this within subject variables box so that we ended up getting something that looked like that. We then have to define our between subject factor, which is our group or exercise intensities. So we can click on group and add it to our between subject factors box. So we end up getting something that looks like this. From here, we can set up our post hoc tests or pairwise comparisons, similar to our two-way between and two-way our two-way independent and two-way repeated measures ANOVAs. We're going to use our estimated marginal means option to set up our pairwise comparisons. So when you click on that button, we will then be presented with the three main effects. So for group, for time, and for the interaction between group and time. We will transfer all three of these over to the display means for box, and then compare our main effects using a Bonferroni adjustment. Clicking continue will bring us back to the main dialog box for the test setup, and then we'll click on the options button so that we can choose the calculations we want to include in the output. So we'll end up clicking descriptive statistics and estimates of effect size, which are the two that are consistent with the tests that we've run so far to date. And then because we have a between subject factor in this mixed ANOVA, we're also going to include our homogeneity tests. So that will give us Levine's test for our between subject factor specifically. We'll click continue. That'll take us back to the main dialog box. We then want to click paste, which will open up a syntax window. And in the syntax window, we'll see our pairwise comparison set up for group, pairwise comparison set up for time, and then pairwise comparison set up for group times time. But it kind of stops here. So we're going to add compare group using a Bonferroni adjustment, and then we're going to do compare time using a Bonferroni adjustment. Once we have our syntax edited, we can click on Run and All, and that will generate our output. Once we get into our output, we then need to check our assumptions. Now remember, we have two sets of assumptions to check this time: Mauchly's test for our within subject factor and Levine's test for our between subject factor. We will go through Mauchly's test first. So in the sphericity table, we can see that we've got a p-value for our within subject factor time, and a p-value of 0.087 is greater than 0.05, so we accept the null hypothesis, and we say that the variances of the differences between time points are equal. Now, when we have our within subject factor and it meets our sphericity assumption, we would then read the sphericity assumed row for both time and the interaction effect between group and time in our ANOVA table. If we have a within subject factor that only has two levels, similar to our example that we had last week, we assume sphericity has been met for both time and the interaction. If, however, we violated, so this is a what-if slide, it doesn't really apply to our example, but if we had violated sphericity and the p-value in this box was less than 0.05, we would then need to consult the epsilon value in the greenhouse geyser box. So if this value is less than or equal to 0.75, you would end up using the greenhouse geyser adjustment for both time and the interaction effect. If that epsilon value was greater than 0.75, we would use the Hune-Felt adjustment for both time and the interaction effect. Okay, so whatever you end up using for your within subject factor is what you use for your interaction effect as well. So that covers Mauchly's tests. For this example, we have assumed sphericity. And then we need to check our homogeneity of variance for the between subject factor using Levine's test. Now you'll see this is a full table, and then I've split each interpretation of each p-value into separate slides just for the sake of space. But in this table, you'll notice that we have three different p-values for Levine's test. Now the reason this is that we check the differences between the variances, or not the differences. We look at the variances between each of our exercise groups, right? So look at the control group versus the low intensity versus the high intensity. And then we say, are the variances equal between all of those levels within the pre-intervention measurements? Are those variances equal in the mid-intervention measurements? And then are those variances equal in the post-intervention measurements? So the number of levels of your within subject variable that you have will end up determining how many p-values you get for Levene's test. So each of these p-values should then be interpreted. For your guys' activity, it's okay if you interpret them all together, especially if all of them meet the assumption of homogeneity of variance. But for the example, I'll go through them one by one. So for the pre-intervention group, we have a p-value of 0.855, which is greater than 0.05. So the interpretation for this one is that we have equal variances between exercise groups within the pre-intervention measurements. If we had violated homogeneity of variance, I would ask you guys to say we have violated the assumption, but keep going with the analysis. Our mid-intervention group had a p-value of 0.597, also greater than 0.05. So again, we accept our null hypothesis and say that we have equal variances between exercise groups within the mid-intervention measurements. And then our last one for the post-intervention, we had a p-value of 0.482, also greater than 0.05. So the interpretation for this p-value specifically is that there are equal variances between exercise groups within the post-intervention measurements. Now, if you end up having all of your p-values being greater than 0.05, I still want you guys to report each p-value and attach it to whichever grouping that it's within, but you could phrase it into one lump, saying that there are equal variances between exercise groups within the pre-intervention, put the p-value for the pre-intervention measurements, mid-intervention, p-value with the mid-intervention measurements, and post-intervention, put the p-value for post-intervention, okay? So you can put them all together, but just make sure you still report all three p-values with each level of the within subject factor that the variances have been compared in. All right. Then, after we've checked our assumptions, which we've met both sphericity and we've met our homogeneity of variance, we can now interpret the ANOVA results. So I'm going to look at the main effect of our within subject factor time. This will show up in the test of within subject effects. Nice and easy to remember. You'll recall that we had assumed sphericity. So we'll read the sphericity assumed row for both time as well as the interaction effect. Now, because I'm going in a chronological order of within subject main effect, between subject main effect, and then the interaction effect, we are going to come back to the interaction effect. So don't forget about this slide. When we're looking at the effect of time, regardless of the type of exercise intensity that people were assigned to, we have a p-value less than 0.001. So the null hypothesis for this p-value is that time has no significant effect on cholesterol concentration, regardless of the exercise intervention that people have participated in. So because p is less than 0.05, we reject this null hypothesis and we say that there is at least one significant difference in cholesterol concentrations between time points, regardless of the exercise intervention. Because we have a significant main effect, we would definitely need to look at our post hoc tests to figure out which time points were significantly different from one another. Then we can check the main effect for our between subject independent variable. This will be in the tests of between subjects effects table. And we have a p-value for group. This was our exercise intensities naming convention. So group has a p-value of 0.020. The null hypothesis for the main effect of group would say that exercise intensity has no significant effect on cholesterol concentration, regardless of when we measured cholesterol. Since our p-value is less than 0.05, we reject this null hypothesis, and we say that exercise intensity does actually have a significant effect on cholesterol concentration, regardless of when it was measured. Again, since we have a significant main effect, we would then need to look at our post hoc tests to figure out which of our exercise intensities are significantly different from one another. The last thing we look at is our interaction effect. So remember I told you to keep the within subjects or test of within subjects effects table in your head, because we had both the main effect for time as well as the interaction effect in that table. In this next slide, I have cropped the table so that way we have room for the interpretation portion. But we have a p-value for our interaction. Again, at sphericity assumed because we had met our assumption for time. We have a p-value less than 0.001. So the null hypothesis for the interaction effect says that there is no significant interaction effect between the exercise intervention and time for cholesterol concentration. We reject this null hypothesis and say that there is a significant interaction effect, which means that we need to look at post hoc tests to figure out which time points were significantly different from each other within each of our groups, and then which of our groups were significantly different from each other within each of the time points. So this is the list of pairwise comparisons or post hoc tests that we need to check based on the significant main effects that we reported. For independent variable A, or my time measurement, my exercise intensities measurement, I'm looking at the control group or my sedentary zero intensity group compared to low intensity and high intensity. When I consult the p-values in the pairwise comparisons table, I can see that I only have one significant pair, and that's between the control group and the high intensity group. So I would list that I have a significant difference between control and high intensity, okay, or a significant difference in cholesterol concentration between no exercise and the high intensity exercise program, regardless of when our cholesterol was actually measured. So this is looking at the differences of all of our control measures for pre, mid, and post. And it's looking at all of our mid and post measure, or all of our low and high intensity measures, again, including all of our time points together. And we identify that there was a significant difference. This is where the significant difference is, okay, between the control group and the high intensity group. Then we can look at the significant effects for our time points. And we end up seeing that we have 3 significant pairs between each of our time points. So time point 1 is our pre-intervention, time point 2 is our mid-intervention, and time point 3 is our post-intervention. So we could list all of these as our pairs, and we would say that all time points resulted in significantly different cholesterol concentrations regardless of the exercise program being performed. And that would suffice. Then we can look at our interaction pairwise comparison. So the first set of pairs that we would look at would be the differences between exercise programs within each of the time points that we collected our measurements. For our pre-intervention measurement, this was before exercise was included, we can see that we have no significant pairs, which is a good thing because this indicates that all of the people we collected were similar in their cholesterol concentrations to start off with. Then we can move down to our mid-intervention measurement, and we see that there's a significant difference between the control and the high-intensity group. So this indicates that perhaps the high-intensity exercise intervention has a faster acting effect on changing our cholesterol concentration. We then have our post-intervention time point at which we are comparing each of our exercise intensities, and we see that we have a significant pair between our control group and high-intensity group, and our our low-intensity and our high-intensity group. So we have three significant pairs as a whole: control and high in our mid and post measurements, and then the low and high in the post measurement. So as an interpretation for these pairwise comparisons, we could say cholesterol concentration was significantly different between the control group and high-intensity group or a high-intensity exercise program at both the mid and post-intervention measurements. So that takes care of these two. And between the low and high-intensity exercise programs at the post-intervention measurement, which accounts for the last significant pair we noted in the table. We then can look at the flip side of those pairwise comparisons and look at the differences between time points within each of our exercise programs, our exercise intensities. So in this table, we have more significant pairs than we did in the last one. In our control group, this is just saying out of the 15 people that we collected, were there differences between each of the three measurements. So in our control group, pre and post and mid and post measurements were significantly different from each other. In the low intensity group, pre and post and mid and post measurements were significantly different from each other. And then in our high intensity group, all of the measurements were significantly different from each other. So we could summarize this into a statement saying that the post-cholesterol measurement was significantly different from the pre and mid measurements for both the control and low intensity groups. That accounts for both of these here. And cholesterol concentration was significantly different between all time points for the individuals in the high intensity exercise program, which accounts for the significant pairs here. So that kind of concludes the results and interpretations of our ANOVA. Then we would have to look at the size of the differences by looking at our effect size. So again, for two-way ANOVAs, we are going to use the partial eta squared effect size value. And again, this represents a percentage of the variability or percentage of the variance that we observe in the outcome variable that is due to the particular effect of the independent variable. So the actual criteria that we're using for small, medium, and large effect sizes is still the same that we've used for the last several weeks. For the effect sizes for the between and within subject factors, you will find those in the ANOVA tables for each respective independent variable. So our between subject variable of exercise intensity has an effect size of 0.171, which is considered large. The partial eta squared value for our within subject factor time was 0.903, which is also considered large. And then we also had significant interactions in both of the pairwise comparisons tables. Now, when we have both a between and a within subject variable, we're going to end up with both univariate and multivariate tests. So if we are comparing the between subject factor within each level of our within subject factor, we end up with a univariate test. And we have our partial eta squared identified for each of our comparisons of our groups within each time point. So for the pre-intervention, row, we had an effect size of 0.016. That would be considered a small effect size for the differences between our exercise intensities for that pre-intervention measurement. Our mid-intervention had an effect size of 0.220, which is considered large. I put an asterisk next to our mid-intervention because that had significant pairs in that particular time point measure. And then our post-intervention similarly had significant pairs within that one. And our effect size in the table is listed as 0.392, which is also considered large. When we compare our time points within each of our exercise intensities, we end up with 3 partial eta squared values. Now, in this one, because we are looking at the comparisons within subject independent variable levels, we're going to end up with a multivariate test table. In either case, to get the effect sizes for your significant interactions, you're looking at the tables beneath the pairwise comparison tables in the output. So for our control group, we ended up with an effect size of 0.386, which is considered large. For the low intensity, we had an effect size of 0.717, which is also considered large. And then for our high intensity, or looking at differences between our time points within the high intensity group, we had an effect size of 0.950, also considered large. Okay, and then again, I put asterisks next to each of these effect size values because they had significant pairs within each exercise intensity group. Okay, that concludes our example for a two-way mixed ANOVA in SPSS.